So we're going to go ahead and talk about the first part of the second packet, and that deals with what is a mole and how to calculate molar mass. Now, so what is important about a mole? Why is it the big deal in chemistry, and why does Miss P have moles all over my room? Now, the reason why I have moles all over my room is not because I love moles. It's because a mole represents how many particles there are present. And it's very much similar to when you go to the donut shop and you ask for a dozen donuts, you know you're going to get 12 donuts. Well, the same goes for a mole. It signifies an amount. So the mole is, like I said, the SI unit used to measure amount. And the key thing here we're going to talk about is amount. And how they discovered, or not discovered, I should say, it is a standard. And how they came to that standard was dealing with carbon-12. And so a 1 mole represents the number of carbon atoms exactly in 12 grams of carbon. So it's a standard. And Avogadro's number is basically how many are in 1 mole. So 1 mole, So 1 mole is going to represent Avogadro's number, which is a very large number. It's 6.02 times 10 to the 23 particles. And when I talk about particles, I actually am representing particles with either a molecule or an atom. So just keep that in mind. Particles means molecule or atom. Now, here is an atom of gold. And if I were to say I had 6.02 times 10 to the 23 atoms, that would be the same as saying I have 1 mole of gold, and it has a mass of 196.97 grams. And the same thing goes for a molecule. Instead of, like the other one was a element, this is for a molecule. Now, here's a molecule of water. Here's oxygen with hydrogens on the sides. And this is 1 molecule. What happens if I have 6.02 times 10 to the 23 together? That is considered 1 mole of water, and it would have the mass of 18 grams. So now that you know that a mole represents the number of particles, we can talk about molar mass. And the molar mass is the mass found on the periodic table for 1 mole of the element. And so the units you're going to see for molar mass is grams per mole. Now, you will hear the word molar mass and the abbreviation AMUs, or atomic mass unit. I'm just going to give you guys a quick deciphering of which is which. An atomic mass unit, so the AMU, that is an arbitrary unit given to 1 atom. So it's a unit for 1 atom of an element. And the molar mass, which I like to abbreviate as MM, is the actual mass of 1 mole of a given element. Now, there's going to be another word that you're going to hear. Sometimes it'll be called the formula weight or molecular weight, and that is the same as a molar mass. That's just another term that chemists or scientists like to use for molar mass. It's formula weight or molecular weight, and it has the units is always just like molar mass. It's grams per mole. There are going to be 2 pieces of information that you really need to know in order to determine the molar mass. And the first thing is you need to know the chemical formula. For example, water, the chemical formula for water is H2O. And the second thing you need to know is the molar mass of each element. So in the example of water, you're going to need to know how much the molar mass for hydrogen and the molar mass for oxygen. And where do you get the molar mass of an element? Well, you're going to need the periodic table, and you should have received one in class. If not, you can always look it up online and you'll get a plethora of periodic tables that are online. So the periodic table really is an important tool in chemistry. It's something that you're going to use almost every day in the class. It gives you so much information, not only the molar mass of each element, but it can even tell you how many protons, how many neutrons, and how many electrons there are in an atom. So the periodic table really is a good source of information. So let's go ahead and take an example from the periodic table. Let's take carbon for an example. There's going to be 4 pieces of information on your periodic table. A whole number, which represents the atomic number. Then you're going to have a symbol for your chemical. Then you're going to have the name of your chemical. And the final thing is the molar mass of your element. Now this is really important, especially for this part of the unit. So we're going to need to know the molar mass of each element. And to reiterate, the unit for molar mass is always grams per mole. So how do we figure out the molar mass of an element? And basically, all you need to do is look at the periodic table. And the molar mass is recorded in the periodic table. So what is the molar mass for copper? It is 63.55 grams per mole. Now, the one thing I also want to include in this lesson is that we can write the molar mass in an equivalent statement, especially when we're going to use it for conversions. It'll be great to use this, be able to write this in an equivalent statement. So, if I were to say write this in an equivalent statement, it would be 63.55 grams of copper is equal to 1 mole of copper. And so that's how simple you can write the equivalent statement for a molar mass. And this is applied to every single molar mass you'll calculate. To find the molar mass of a compound or molecule, you need to take the sum of the individual atomic masses in which the chemical formula is comprised of. And before I do that, I'm going to give you guys my steps. And in order to do calculating molar mass for compounds, you need to know, you need to have a periodic table. The second step is you need to know the chemical formula and list the elements in the formula. The next one you would do is basically count. Count how many of each element is in the formula, the chemical formula. And this is where subscripts come into play. Next, you're going to take the molar mass of your element and multiply it by the number of each element. And finally, you're just going to take the sum. So you're just going to add up the molar masses of all the atoms in the compound. So let's go ahead and do this in practice. Here is a chemical formula, H2SO4. This is the chemical formula for sulfuric acid. And if you notice, there are subscripts. Now, these subscripts tell us something. These tell us how many of each element there are. So let's go ahead and do the steps. So the first one is you need a periodic table, and I've been nice and I put the information from the periodic table right here so that we don't have to go look for it. The second one is we need to list all the elements. Now that we have the element, we have H for hydrogen, S for sulfur, and O for oxygen. This also tells us how many of each there are. Now, since there are subscripts for hydrogen, it says 2, I know that there are 2 hydrogens. Sulfur, if you notice, sulfur has no subscript. So we can assume that this is equal to 1. So there's only 1 sulfur present in the chemical formula. And there are 4 oxygens present. The next step is that we need to figure out the molar mass of each and multiply these guys. So hydrogen, if we look, has 1.0, and I'm going to shorten this to 2 decimal places, 1.01 grams per mole. Sulfur is 32.07 grams per mole. And oxygen is about 16.00 grams per mole. Now I can go ahead and plug into my calculator, and it should give me numbers. Hydrogen would be 2.02 grams per mole. Sulfur is 32.07 grams per mole. And oxygen is 64.00 grams per mole. Now that I have each one, my final step is taking the sum. So I need to add 2.02 plus 32.07 and 64 all together, and you should end up with a molar mass of 98.09 grams per mole. And this is how we would calculate the molar mass for a compound or molecule. Now, I'm going to show you another example because they're slightly different. If you notice an example, there are parentheses. So, and outside of that parentheses is a number. So what we need to do is, just like the other one, we know how many of each there are. Now, we have nitrogen, it has 1 right now because it has no subscript, and hydrogen has 4. But because it's in parentheses and there's this number 3 outside the parentheses, we have to do what in algebra you would call the distribution. So if we were counting these up, so let me go ahead and write our elements N, H, P, and O. If I were writing this up, counting this, I don't have 1 nitrogen, but I have 3 because it's 1 times 3. And hydrogen, it would be 4 times 3, so that's 12. Now, P and O4 are not in the parentheses, so we don't have to distribute. So P, in this case, has only 1, and O, which is oxygen, has 4. Now that I know that, I can go ahead and look for it on the periodic table, which I've nicely done right here, and multiply each one by its mass. So I'm going to go ahead and shorten this to 14.01 grams per mole, and hydrogen is 1.01 grams per mole. Phosphorus is 30.97 grams per mole, and oxygen is 16.00 grams per mole. I can go ahead and put all of these into the calculator, and I should end up with the following: 42.03 grams per mole, 12.12 grams per mole, 30.97 grams per mole, and 64.00 grams per mole. Now our final step is just taking the sum, and you should get with the final answer of 149.12 grams per mole. I hope this is making sense on how to calculate molar mass. And so, just wanted to summarize it again. The first step is you're going to use a periodic table to determine the molar mass of each element. Then you're going to list the chemical elements in the chemical formula. Then determine how many of each element are in the compound. And then you're going to multiply each element's molar mass by the number of atoms in the compound. And then take the sum. And with that said, this is how you calculate molar mass and what a mole represents.